hello, we're doing 2.3 matrix equations. That means two matrices equal to each other. Let's look at this. So we have y equals this. The positions, y equals 2x minus 1. Right under it, I'm going to say x equals y minus 5. Y minus 5. It just got weird there. Let me rewrite that. Y minus 5. There we go. I like that better. And what you have to do is solve these. You have to solve. The directions will say solve for x and y. Doesn't matter how you do it. So I thought this would be a good opportunity to review something we normally don't talk about, which is substitution. So let's try substitution. If we take, and these are both solved for x, well, this is solved for x. So x equals y minus 5, which means that I can plug y minus 5 right in there for that x right there. So I will have, now if you want to do elimination, you surely can. But I'm just reviewing maybe a lost art of substitution here. So I'm plugging in y minus 5 right here in for this x. That's what I'm doing, minus 1. And now I have this down to one variable. So y, and I'll distribute here 2y minus 10 minus 1. That's that minus 1. We'll clean this up. Y equals 2y minus 11. And let's see, we'll take the 2y over, I guess. There's lots of ways you can do it. You can skip a whole bunch of steps from here, but this is minus 1y equals negative 11. So y would equal positive 11. All right, y would equal positive 11. So you would divide both sides by negative 1. And then you could get x by simply plugging it in this one. So x would equal 11 minus 5, which would be 6. And you can check these. That's the beautiful thing about this. You can certainly check them. If you just erased everything, watch, I can't really erase this because it'll turn into white blobs. But if I put in 11 right here, let's say that's 11, and x is 2 times 6 minus 1, they should be equal. 11 equals 12 minus 1. See that? You can check it. On this other one, it's actually easier. 22 is actually way easier. Let me try to prove it to you. I'm going to write all three. But instead of writing them vertically like this, I'm going to write them sideways. Watch. Equals 10 minus x. And then all you got to do is solve these for x and y. You can do whatever you want. Can I take this and solve this for x? Definitely. Just divide that by 6 and boom, done. So that's my x right there. And from there you could plug it back in. Or I could just solve this for y right here. And if I am going a little bit fast on this, you can always back this up and watch it again. But this would be 1. So y would equal 1. And x would equal negative 2. And you can certainly check it. Let me just show you how to do that real fast. You can check it in this problem. So that'd be 12 times 1 equals 10 minus negative 2, which is 10 plus 2, which is 12 equals 12. And that's a double negative. That's what I did right there. I kind of ran out of room. But that's really matrix equations, like the intro version, part 1. I'll talk to you later.